A new STMicroelectronics microcontroller always makes people run around. And with the U3 and the WBA6 series, actually there are two new microcontrollers released today on the 4th of March. And in this short video, I wanted to give you an overview of both of the new chips with the information that we have today. This video is not going to be an all-through review of the chip, but instead I want to give you quick guidance to decide, is this thing relevant for me? And if yes, how can I use it? What is for now, for us, the most important question is what core do they use? And here we see they use an ARM Cortex M33 with 256 kilobytes of RAM and 1 megabyte of remnant storage. And then the actual product palette presents itself like so. All of them at 96 megahertz, and we see there are some which also have a cryptographic module and others which don't. And yes, as a standard, all of them come with I3C, and also what is interesting, they support the new FD-CAN. So if you want to interact with I3C or with FD-CAN peripheral devices, these microcontrollers have you covered. To start with the STM32U3, we see here the most important passage is this here, where they claim that they use a near threshold design. They also sent the press release out about that, where they claimed some kind of AI involvement. But you know, if you punch your girlfriend and you say you use AI to decide to punch her, suddenly it becomes stunning and brave. So this is probably just some BS. And yes, just in case anybody doesn't believe me, here you've got it in yellow and again in yellow, that it's some kind of AI-driven process. So we're going to look at that in a minute, because we see here that they claim significantly better performance than on the U5 and the L4. And because microcontrollers have different RAM sizes, it's always a bit difficult to compare. And here I'm going to compare this guy here, which has 256 kilobytes, with this guy here, which has 320 kilobytes. So there might be a slight difference between this and this guy, not only due to the core, but also due to the amount of RAM it has. And thankfully, in the front page of the datasheet, as you see here, we get this kind of comparison of how the two systems perform. And of course, what is the most important is when the thing runs, we've got these two here. It's microampere per megahertz. And here we also have microampere per megahertz in the various modes. And of course, we need to compare these, so we need to multiply these with the maximum speed to find out how much the controller will actually draw in a specific situation. And what I find interesting is here that we see there are multiple stop 2 and stop 3 modes, and in some of them a part of the remnant memory is eliminated on the new chip. On the old one, we don't have that, but the consumption is kind of lower on the older one. And if we dig deeper into the current consumption in standby mode, we can search for this string here, which you find in almost every ST datasheet. Also this one here. And what makes it interesting is that here we see they use a nanoampere as a unit, whereas here they use a microampere. So they want to meddle a little bit with the data. And of course it's gonna be a big task to tear this down. Let us just take one here, the standby current, no independent watchdog, 1.8 volts at 25 degrees. And this is in microampere. So we get ourselves a little Google converter. I am lazy. We put in 0.12. We get 120 nanoampere. Now we go to the other one. And we see something strange. 120 versus 108. So the older part might just be a little bit more efficient in this situation. And then for the rest here, we have again all these comparisons. Here you see, for example, they say code with data processing. Here on the other side, they use Cormac. So there always is a bit of a middle room to make the things, how should I say, more interesting. But for most of the cases, especially when running, there is a significant reduction in power consumption. And when we see here for the new and for the old, by and large, we get the same housings. And when we compare some of the pins, such as here, we see that they are very, very similar. So in most cases, like in many other SGS Thomson microcontroller families, you can simply shoot a one-off prototype by replacing the old STM32L with the new U3, modifying the software a little bit, and then doing your own measurements to get an exact pulse of what we are actually looking at. And now the funny thing is, how can I actually buy them? Because the announcement promised that the parts would already be available. And if I now go here at OEM Secrets, then I get this here. So we see at the moment, none of the distributors has them in stock yet. But as usual, this should change relatively quickly. And incidentally, it's not yet possible to request a sample either. And this brings us to our next friend, which is the WBA, which has been expanded with a new family called WBA6. And this diagram here on the screen already shows us essentially what we need to know about the WBA6. It's a WBA5 which has more flash and more RAM. You can see it here in the comparison. They greatly increased the memory capacity. And in many of the cases, you can also crisscross between the two. So if you have a WBA5 based application which needs more memory, again, just like we discussed with the U5, it's more or less a one-click replacement. And incidentally, all those who want a module so that you can use it like an Espressif ESP32 or something, these modules are coming, But as you see here at the very bottom of the table, for the WBA6, they will only be coming in the fourth quarter of this year. And for this thing, there is one more interesting aspect. If we look at the very left-hand side, we see that there are multiple different families available. And the WBA6-2, which we see here, is Bluetooth only, while the WBA6-3, 6.4 and 6.5, here we have the 6.3, also support Zigbee, Thread and Matter. And in the datasheet, they furthermore promise a slightly more sensitive receiver for the whole WBA6 family. And the three relevant passages, or rather two, you have here. What you see here is they add USB high speed and claim that they add a few more GPIO interfaces. But interestingly, on the WBA6, they still stay with I2C and they didn't give the thing I3C, at least yet. And with that, I wanted to thank you for watching. Please leave a like and a comment below. If you have any questions, I can always reach out to STMicroelectronics and get them answered. And with that, I thank you for your attention. Bye bye.